Hey everybody, welcome back. Today we are going to go over data of the big variety and how it can apply to your cloud applications. Now, big data is a kind of a buzzwordy term that I am sure you all have become intimately familiar with in your various roles at your companies, or if you're not working, you probably have at least heard it in various tech postings. But if not, just for the sake of things, we're going to talk about that today. We're going to take a peek at what is available to you as cloud service and how we can use it to our advantage. So let's get started here. Now, this was supposed to be maximized. Please maximize, thank you. So, big data is a nebulous term. It's always changing. And all it really means is a massive, massive, massive amount of information that you have to deal with. Now, it is typically used for analytical purposes. Um, it is typically used for housing, lots and lots of records. Basically, just kind of the key takeaway here is that your standard relational databases are probably going to crash and burn in the face of big data. Now, these tend to be multi-gigabytes, petabytes, zettabytes of data, not, you know, 200 employee records or something like that. And the other kind of changing definition of what big data is are the number of V's that we have associated with them. Commonly accepted to be 5 V's. I've seen up to 30 defined, kind of depending on your perspective and how deep you want to get into it. But effectively, they're just words that start with V that describe something. So first there's volume. So I've got a nice little graphic here. There's a massive amount of data. Okay, again, petabytes is probably the current standard-ish of how much we're dealing with, but that's constantly going up as we keep generating more and more information to deal with. But the more interesting ones, at least to me, because obviously big data, massive amount of data is a problem to deal with. But sometimes this data may come in multiple varieties. So the data you're receiving and that you might have to store and manage might not always be in the same format. Typically, the data that we have in a big data environment is schema-less, meaning we can't easily drop it into a relational database with an enforced schema. It's probably going to be like a NoSQL type of database where it's a JSON packet or it's some kind of a loosely defined structure where the schema is enforced by whatever application is processing it, not the database server. So you might have uncertainty in your data types that you're managing. Value I'll leave off to the end because that's a more businessy one, but there's also veracity. So maybe there's uncertainty in your data set. We could have conflicting information. Maybe we're missing some data. Maybe we have inconsistencies in terms of the values that we're recording or in variable types or in, excuse me, units for the data. So maybe something's being read in Fahrenheit, something's coming in Celsius, something's coming in gigabytes versus megabytes versus terabytes for like a recorded storage value. Maybe some data is missing, right? The key is that with all of this data just streaming in, there might be issues with the actual data itself. We also have velocity. The type of data that's being sent to a big data application is probably bursty or it's coming in at a constant stream, which are two ends of the opposite spectrum there, right? But it's probably coming in pretty quickly. And your applications have to be able to consume that data, process it in real time, and then make decisions based on what they're getting. A common example would be a sensor network consistently blasting out packets of recorded data to some central server, which has to aggregate all of this information from, possibly thousands of little sensor motes all around, come up with a clear picture of the environment around it, and then make a decision on what has to be done. And if we're talking about sensors, you're probably getting little tiny values, but over time that will build up. Then the other one that I left off here is value. This is another very common term with big data. It's taking all of this information and gleaning something meaningful for your core company, your values, basically. Can we make business decisions based on all of this data we've received? When you look at topics like data warehousing, this becomes very, very common. Let's pivot our business in this direction based on all of this information we have received and gleaned from. So the key is that, the definition is constantly changing, but you're dealing with a massive amount of information that is constantly changing, constantly being updated, with possible inconsistencies inside of it. Now, with big data, it's kind of interesting to talk about the size. So here's a couple of images from Google, and thought this was bigger. But a petabyte of data is a stack of floppy disks higher than 12 Empire State Buildings, if we all remember what floppy disks are, hoping you do. Every tweet ever tweeted times 50, but it's also small. So we can encode 2 micrograms of DNA in a petabyte of data, or 1 day's worth of videos uploaded to YouTube. Again, this is probably going to be dated by the time you watch this video, but effectively a petabyte is just a massive amount of information. Okay, and you have to figure out how to store that and manage it. And your cloud applications will probably have to deal with this type of thing, right? It is not out of the realm of possibility that you have to consume massive amounts of data. What if you're running a social media site? What if your application is dealing with thousands of users concurrently, streaming information into your platform? This can very, very quickly become a big data problem. That's what big data is. But now we can look at some of the tools that we have available to us. And you're going to have, labs to work you through some of these technical concepts so that you can get a feel for them. But in terms of at least Google Cloud, there is some really nice power that we have in here. And this is really going to be in terms of technologies like BigQuery, Bigtable, and some of the database related tools like there's Cloud Spanner as well, which we'll look at. Bigtable is an implementation of a NoSQL database. It's basically like a massive relational type table. Give you a nice, comfortable format, but it's still kind of NoSQL-esque. And to get you going with BigQuery and Bigtable, BigQuery is basically the SQL language interface to Bigtable. Very, very powerful, very, very fast. You can search through the entirety of GitHub, which is a ton of information in seconds, which is one of the labs that you'll hopefully be doing, assuming I can get that up and running again. But let's take a quick look at what is available. So I went into BigQuery. So this, I just searched for BigQuery, and they make a bunch of publicly available data sets available to you right off the get-go. So there's this BigQuery public data set with a whole bunch of sub data sets involved. So you could do Bitcoin checking. You can look at Chicago taxi information. There's COVID-19 related data sets too, if any of you are budding researchers and interested in analytics. There's a lot of publicly available data that is out there. FDA information. So here's the GitHub repos repository. Contents from 2.9 million public open source repositories, including commits, including tags. So all of the information that you could need to do a data mining, research activity is available to you in here. So let's take a look at what we can do though. So I had an example here, and I'm going to try to do it from memory, so excuse me if I screw this up. But there's this COVID-19 data, and we can pull some staffing information. So if I wanted to compose a query, again, this is going to be very SQL-like. There are some minute differences, but they did their best to at least stick to a comfortable format. And if Google is watching this, I apologize for misinterpreting your intent. But let's say I want to just get everything related to this staffing table. So I could do something like select. My cursor's all wonky now, I see. Everything from, so we have to pick the data set, which is BigQuery public data. Oh, good. It actually didn't autocomplete last time. That's why I was surprised. .covid-19 AHA.staffing. Backtick. Zoom in a little bit so you can see this. Can I make you smaller? Yeah. So, and if I were to run this, so this basically says it's going to process about 740 kilobytes. Obviously, this is a smaller data set, but I could scale this up, and we'll take a look at the GitHub one momentarily too. Run. So going through this data set, 2.5 seconds. Okay, so here is a whole bunch of staffing information related to COVID-19, basically. And I honestly don't know what any of these fields mean. I just know that it is a data set that I could query if I was interested in, COVID staffing. I can also look at, let me zoom back out so that I know how, or I can see what to type here. This editor has honestly changed since the last time I used it too, so apologies for the unfamiliarity there. Where'd yes go? I guess I don't get the option to not save it. Okay, let's refresh the page. That usually fixes things. Reload. Okay. So let's run public data. And let's look at the GitHub information. GitHub repos. Sorry about that. Cut all that out. Sorry, I had some stuff happening off screen that was really, really loud. So let's search through the GitHub repositories now. Select everything from BigQuery public data dot GitHub repos dot commits. This will process 804 gigabytes when run. Let's maybe try to trim this back a little bit. Let's get all of the subjects. So let's select subject. What's that going to be? 10.5 gigs, a little bit better. The only other thing too with this is that once you start running queries, this will eventually charge your account balance if you process a certain amount of data. So we'll give this a shot and see. I just want to see like the timing to demonstrate what's available. One of your labs that I'm hoping will be feasible still. I say still because I haven't recorded it and I'm going to put it up after this. But it was to search through the entirety of GitHub for the statement to do or TBD. And it's always wonderful to see the millions of to-dos that are up on GitHub publicly right now. All right, so we are searching 10.5 gigabytes of data. And I just want to get every single subject in all commits. And try to, if you're not necessarily clear on what I'm doing here, maybe think of doing a standard SQL query, so like a MySQL, Microsoft SQL, SQLite. Think about processing 800 gigabytes worth of records in, I think it was 47.6 seconds. Okay, so here are a whole bunch of status messages for commits across the entirety of GitHub. 10.5 gigs of processed data. Not too shabby. Keep in mind that you could do this from something like a Raspberry Pi and you'd get the exact same performance. Tiny little microcomputer running a big query command, 40 seconds to process, 10.5 gigs of data. Probably a little bit more for that whole 800, but I didn't want to kill my account balance. Anyway, that's all for today. Hopefully this was informative for you. You will get some practice with BigQuery, Bigtable, and all of that fun type of stuff in the near future. So see you next time. Bye, everybody.